UML sequence diagrams are interaction diagrams that detail how operations are performed. They capture the interaction between objects in the context of collaboration and show how elements interact over time and are organized with respect to object horizontally and time vertically. The horizontal axis shows elements that participate in the interaction, and they can appear in any order. Typically, objects participating in an operation are listed from left to right according to when they participate in the message sequence. The vertical axis shows the progressing time, but note that time in the sequence diagram is denoted in the context of the execution order, that is, the sequence itself, and not the actual duration. There are timing diagrams just for that. The vertical space in the interaction diagram has nothing to do with the duration of interaction. As an example, we will consider the hotel booking service. The object that initiates the message sequence is the reservation window. Note that class and object diagrams are static model views, but interaction diagrams are dynamic. Let's look at the basic notation of the sequence diagram. Actor, a type of role played by the instance that interacts with the subject, for example by exchanging signals and data. Actors represent the roles played by users, external equipment, or other actors. Actor does not necessarily represent a specific physical entity, but simply a specific role of some entity. A person can play the role of several different actors, and conversely, an actor may be represented by multiple different people. Lifeline. It represents an individual participant in the interaction and displays the passage of time. Activation. The thin rectangle on the lifeline indicates the period during which the element performs an operation. Top and bottom of the rectangle are aligned with the start and end of a specific function. Call message. Used to call procedures, execute operations, or designate individual nested control flows. One end of the arrow always touches the control focus or lifeline of the client object that triggers the message. The tip of the arrow points at the lifeline of the object that receives the message and takes action as a result. At the same time, this object also often receives a control focus, becoming active. The message can be synchronous, depicted with a filled arrow, when the client sends a message, for example, to the server and waits for a response before doing anything else, and asynchronous, depicted with a regular arrow, when the client continues to perform operations without waiting for a response. Return message. Return message identifies the specific communication between the lifelines of an interaction and represents the transfer of information to the caller of the corresponding message. Self message. A participant sends a message or command to itself. Create message. In the case of creating a participant, we draw an arrow pointing at the participant's rectangle. If the participant will perform something immediately after its creation, then straight after the participant's rectangle, we will need to draw the activation. Destroy message. The destruction of a participant is indicated by a large X with an arrow pointing from the participant that initiates the destruction towards the one that is going to be destroyed. If the X is drawn at the end of the participant's lifeline and there is no arrow from another object, then this means that the object deletes itself. In other words, self-destructs. Note or comment gives the ability to attach various nodes to elements. A comment carries no semantic force but may contain useful information. Focus of control. This is essentially any point in an interaction where something happens, and it is drawn as a tall, thin rectangle on the lifeline. Since the control focus represents a period during which an element is performing some operation, the top and bottom of the rectangle are aligned with the initiation and completion time respectively. UML 2.0 introduces sequence or interaction fragments. A sequence fragment is represented as a box called a combined fragment that includes some of the interactions within the sequence diagram. The fragment operator in the top left corner indicates the type of fragment, which can be one of the following: Alt, multiple alternative fragments. Only the one whose condition is true is executed. Message or group of messages is separated from each other by horizontal dashed line. This type is used to simulate conditional statements like if, then, else, and select statements, case or switch. Opt. The fragment is executed only if the provided condition is true and it is a call to an additional message or group of messages under some condition. It is similar to the alt fragment when the shorthand conditional statement if then is used. PAR. Parallel message processing. Message or group of messages processed in parallel are separated from each other by horizontal dashed lines. Loop. As obvious as it looks, it is used to simulate loops. Break. Early termination of message processing on condition, used as a part of other fragments, usually loop. Critical. Exclusively processed message or group of messages, used as a part of other fragments, usually PAR. Implies the suspension of any messages processing in a more general fragment for the duration of message processing inside the critical subfragment. Neg. Message or event generated as a result of the inability to process another received message. For example, if the time for entering the password has expired. Then, instead of returning the password, the timeout message will be generated. Assert. It's when a message or group of messages executed after some condition has been pre-checked. If the condition is negative, then no message is sent. In programming, this technique is always used to localize errors. Strict. Sequential message handling. Consecutively processed messages are separated from each other by horizontal dashed line and processed strictly in turn from top to bottom. Sec. Non-strict sequential message processing. Messages are separated from each other by horizontal dashed lines and can be processed in any order except for messages received by one object. Ignore. Messages that can potentially occur in the fragment and that are listed after the word ignore in curly braces will be ignored. Ref. A reference to a portion of the interaction defined elsewhere, perhaps in a different diagram. This element is similar to predefined processes in flowcharts or interaction overview diagrams. SD. Used to surround the entire sequence diagram. Now that we know what's what, let's use our knowledge to model a script that consists of some use cases. In our case, customer requirements are described as use cases that are formalized in the script. As a reminder, a use case is a set of interactions between external actors and a system. To be more precise, a specification of a sequence of actions, including variants that a system or object can perform, interacting with actors of the system. A script is a thread that describes a sequence of events that occur during one particular execution of a system that is often represented by a sequence diagram. For example, in this sequence diagram, there are two scenarios, the main one and the alternative one. Following the main scenario, the buyer enters the author's name in a search box and clicks the search button. The system validates the search query. If the validation passes, the system searches the catalog for the author's books. When the search is complete, the system displays its results. An alternative scenario is rather short. If the buyer did not enter the author's name but clicked on the search button, then the system displays an error message.